Hello, so today we're going to start with this problem called non-overlapping intervals. Okay, so let's see. So we have intervals where each interval has a start and end time, and we want to return the minimum number of intervals we need to remove to make the rest of the intervals non-overlapping. So we want to minimize the number of intervals we remove so that we can have the rest non-overlapping. Okay, so I guess minimizing the number of intervals we need to remove, that's just equivalent to maximizing the non-overlapping intervals. So maximize the non-overlapping intervals. Okay, so let's start that one. Okay, so how can we do that? So yeah, this is just a classic scheduling intervals greedy algorithm. So we need to first sort the intervals by finish time, which is the last value. So that will be key equal to lambda x, and then we can just do x1. I think this is the syntax, if I remember correctly. And then we need to go through them. So go through intervals, and in the sorted order, of course, and just remove any interval that overlaps with the previous one. So a greedy strategy here. So we need definitely to have a pref. So what are the start and end date? They start from 1. So let's start with pref end, call it, and start with it equal to 0. And in intervals, okay, so we would have start and an end. Okay, start and finish time, and then here we can say if previous finish, let's call it that, is different than 0, bigger than 0, and we need to count the overlapping intervals, the ones to remove. And so now if prev is bigger than 0 and this finish time, right, is smaller than the prev f, that means we overlap, and at that point to do count plus 1. Otherwise just continue and we can do count. Okay. Okay, so let's run the code here. Yeah, 0 here actually. Okay, let's just make sure our intervals are sorted here by finish time. Oh yeah, I'm never assigning prev, right? Which is bad here. So when do we take the interval? That's only in the else. So here prev f is equal to the finish time. Sorry. Because this means we are taking the interval. So here, keeping the interval. And here only if the finish time of the current interval is smaller than the previous one, then we remove it. Okay, so 1 2 2 3 1 3 3 4, so we should only need to remove, so 1 2 2 3 don't overlap, so we should be good there. 3, we should remove 1 3, right? So let's see. F is equal to f, and then prev f is equal to, okay, okay, so we start out with the f equal to 2, right? So prev f was 0, so we should be good there. We should go to the next one. Okay, so let's just print keeping interval. unless here print removing interval. Let's see what we get. Okay. Actually, I would prefer to do something like this. Okay, so for this one we are keeping the interval, for the next one keeping the interval. Now for this one, it's actually the ends are equal, 2 3 1 3. The problem is the ends are equal, but they do overlap, right? So yeah, we need to do more check for overlapping. So if start, yeah, we need to keep both actually. So okay, previous, okay, and let's just call it none first. So here if prep, and here let's just say prep is going to be equal to the interval. So SF. Or we could do SF equal to I. So do this I and then call this I. Okay. And now here only if S is smaller, right? Then so here this one is smaller, right? So S is smaller than prev 0, or F is smaller than prev 1. Okay. What about if they are equal, like S equal to prev 0, right? So that would be 1 maybe 3, 1, 3, so they certainly overlap, right? What about if, say this is bigger, 2, but this is equal? Yeah, need to do equal. The problem is something like, the problem is it shouldn't work for something like this. 2, 3, right? Okay, let's see here. Okay. Okay, so the second example seems not working. This example here doesn't work. Yeah, because they are the same. So normally we should have for that one output 2. We need to remove 2 because they are equal. I'm not sure if we need to do equal in all cases. Actually, just for the start, because the end can be not the case. Because this one should work 1 2 2 3. Okay. Let's try to submit. Okay, there is this case. Gives the wrong answer. Okay. So I'm saying 2, so I'm removing too much. Let's see, so we shouldn't take this one, right? So when we sort this one by finish time, let me first take these examples and push them here, then take only this one, sort the intervals. Okay, so what we have here is so we only remove, so basically when they are sorted we get this. So this is the sorted version. So if you take a look at this, well, we could take this one, but then we shouldn't take this one, so we remove that one. And then we can take this one. And then we shouldn't take this one. And so we remove two. I think this is what my algorithm does, but can we do better? Okay, yeah, my algorithm doesn't do this for some reason, it seems, because it's keeping this one, but then it's keeping this one. So because S is 2 and the previous one is 1, right? So it's not within it, it's not included. So my overlapping logic is wrong. So actually what we need is just to check that the start time of the interval is, if it's smaller or equal to the finish time of the previous interval, then that means we overlap. Okay, so like here we have two intervals here. What are the cases for overlapping, right? So let's call this one E1, E2, and let's see what are the cases for overlapping. So it could be that one, it could be this one, and then what else? It could be like they are like this. What else? Those are the only two cases. One other case is this one is non-overlapping. So non-overlapping would be, can be like this, like they just meet at the same value there, and these are the overlapping cases. Okay. Then okay, another thing also with non-overlapping that is possible is something like this. So it can be like that, and then yeah, other cases are like really too far, something like this. Or another case would be similar to this one, except they are really too far again. Okay. Cool. Now, so let's see. So this, let's call this one prep, right? Or yeah, just E1. So this one here, well, E1 start is smaller than E2 start. E1 finish is smaller than E2 finish, right? This one here, E1 start is bigger than E2 start, and E1 finish is bigger than E2 finish. This one, they are both equal. Okay. Now how can we define a rule with this? So we could do, so this one though, non-overlapping I1 is smaller than I2S, but I1 finish is equal to I1s, and then I2 finish is smaller than I2 finish, right? Similar thing here, except the reverse. I1 start is bigger and I1 finish is bigger. Okay, now these are even like, these are like the usual ones. So for this here we can say I1s plus then I2s, basically this value here equal to this value here. So either both are smaller or both are bigger. Okay, but we need equal as well, right? Or they are both equal. Okay, okay, and so let's define overlap I1, I2, and then return this value. And then to replace s with 0, replace this with 0. And then 1 here. This is 1 as well. And this will be 0. 0 here. Yep. And then 1. Yeah, we need to use that. So overlap yeah, this needs to be all. Okay. Okay, now let's take the use cases here. Okay, it seems like it's still wrong on one of them. So the second one, for example, is wrong for some reason. It's saying 2. It's saying that these two are. So for the second one, that's like here we should remove only 1, 3, but it's saying that we need to move 1, 2, even though it has no. Sorry, 2, 3. 2, 3 is equal to the finish time. 2, 3, the start is equal to the finish time, right? So equal. Okay, let me not do anything fancy here. So I'll say and then let's say for the other one, or is bigger and it's bigger. Okay. Okay, so either this one here or this one here. So we can remove this, or that one. And this one actually is just I1 equal to I2. Okay, y 2 3 and 1 2. So 2 3 and 1 2. So these would give us 1 2, right? So that's the first thing, and then we would get 2 3. So it should be there. Basically, if we do this one is I1 and this one is I2, what we'd get for this is that I1 dot start is smaller than I2 dot start, and then I1 dot finish is smaller than I2 dot finish. So it says that they overlap, right? Okay, so this is wrong. We need to say that minus yeah, that's a little bit complicated. It should actually, yeah, a lot simpler, be a lot simpler than this. So not all of this, we just need to check that the start time of this interval, so I0, is bigger or equal than the previous one's finish time. Yeah, that should be enough. Okay, so I'm sorting by end, and all we need to do is to make sure the intervals start time. So the interval start time is bigger or equal. Oh, so this is valid. So smaller is the one when we want to remove it. Okay, cool. And then we could just take this, these example test cases. Okay, and then add this other one. Okay, so that passes. Cool. Yeah. Okay, so let's clean it up a little bit more. So let's just make this SF, and then this is S, and let's call this previous finish time. So that will give us F here, and we could just use that. So print F. Okay. Yeah, this should be still. Could it be the last interval? So take a look at the last interval. Okay, so let's actually, yeah, this count thing is a little bit ugly. So let's just first just keep do it like this, count the non-overlapping ones. That way we can just check if do the else, which is if not pref or s is bigger or equal to the previous finish time, then we could do that. And then the count now is the counts of the non-overlapping. So non-overlapping. So non-overlapping here would be 0. And then we can say, okay, non-overlapping plus 1, and then here minus non-overlapping. Okay. Or maybe it's because of negative values, right? Because, yeah, for negative values, this would be, so let's just cut it to, okay, something like this. Okay, so for negative values, right, 98 and 99 are indeed overlapping, but this one and this one are not, so these should be counted. But do they verify the structure of this here? So s would be equal to, so we will be here, and s would be equal to minus 98, and pref would be equal to minus 98, right? And so that's equal, so that's fine. But what about this case here? Okay, that one is overlapping as well. But what about 95, 93, or 96, 94? Okay, 96, 94. Okay, so let's get rid of this one. So that would mean this here is the one we are talking about, this one here. Okay, and now s is 96, and then previous f is 96 as well, equal, yeah. Okay, trying to find the case where, okay, let's say if I had this as, you know, 94 and this as 92, right? So 96, and here the previous f would be 90, this would be 94. And so is s bigger than pref f would mean basically if minus 94 is bigger or equal to minus 96, which (94) is considered smaller, right, than 96. So actually 94 is considered smaller than 96. And so that's wrong basically. And so here what we need to do, if we were to take the absolute value, what about 94? This would be, we'll say, smaller. And 94 is actually bigger, so that's true. So that should work. Okay, so Yeah, something seems wrong here. Let's just try to adjust this a little bit. I don't think negative values are fine. Let's first just replace this with the current interval, and call this current, and then make this just the interval, and this would be current end time, and this would be interval start time, and here current. This would be equal to I, and yeah, that's pretty much it. Okay, cool. So that passes. Let's check with the other test cases. So let's add these here. Okay, so that passes. Cool. Let's submit. Okay, so that passes. Cool. Cool. Yeah, so that's it for this problem. Thanks for watching and see you on the next one. Bye.